Let's go ahead and try another wheel and axle problem. And so we'll draw ourselves a wheel, and in the center we'll draw ourselves an axle. And then right in the middle we'll draw ourselves a turning point or a fulcrum, and then we'll draw an imaginary line to represent where we will apply our forces. And on the inner circle or the axle, let's apply a force resistance of 550 newtons. And on the outer circle, let's apply an effort force of 300 newtons. And let's say our outer circle or our wheel has a diameter of 16 centimeters. And then our inner circle or our axle has a diameter of 8 centimeters. And so my question to you is, what would be the percent efficiency? And by now you should know your percent efficiency equation. It is just your AMA divided by your IMA multiplied by 100. So we'll put AMA on top and our IMA on bottom. And just so there's no confusion, let's go ahead and clear this up right now. Since we're looking for our efficiency, we're going to go ahead and assume that there is no ideal effort force. So there's no FE in an ideal world, because this isn't an ideal world because we're dealing with how inefficient this system is. Therefore, we can say that the AMA does not equal the IMA. So we'll say AMA does not equal our IMA. But let's see what our AMA does equal. And to find that out, we'll use our AMA-free equation. Our AMA is equal to our FR divided by our FE. And we know both of those numbers. We know our force resistance is 550 newtons. And we know our force effort is 300 newtons. And of course, newtons cancels out. And to find our AMA, we're going to need our handy-dandy calculator. So we'll say 550 divided by 300. And what do we get? We get 1.833 repeating. So let's go ahead and just round that to 1.83. And for our IMA, we'll use our Imadeer equation. So we'll say IMA equals dE divided by dr. And if we look, our force effort is applied on the outer wheel, which makes our outer wheel our distance effort. And our inner wheel is our axle, so that is our distance resistance. And so for our distance effort on top, we'll write 16 centimeters, and on bottom, we'll go ahead and write 8 centimeters. And of course, centimeters cancels out, and hopefully you don't need a calculator for this, but just in case, let's say 16 divided by 8 is just, of course, 2. And so we get an IMA of 2, and of course our AMA is supposed to be smaller than our IMA. That is the laws of physics, and remember, you're not allowed to break the laws of physics in your engineering classroom. But with that, let's go ahead and solve for our percent efficiency. And so we can go ahead and write out our equation. Remember, it's your AMA divided by your IMA multiplied by 100. And we know our AMA is 1.83, and we found out our IMA is just 2. And so this is equal to our percent efficiency. And to figure this out, let's go ahead and plug it into our handy-dandy calculator. We'll say 1.83 divided by 2 multiplied by 100. And we get about 91.5%. And I guess if you look at it, it doesn't really look like it's about 91.5%. It looks like it's exactly. But remember, we rounded our 1.83. And so since it's not exactly 1.83, it was 1.83 repeating. It's not going to be exactly 91.5%. But we'll go ahead and say, for simplicity's sake, that our percent efficiency is 91.5% in this system.